we are going to be adding and subtracting rational expressions. So unlike multiplying and dividing, when we're adding and subtracting, you do have to find a common denominator. So anytime we're adding or subtracting, we have to have that denominator to be the same. Okay, so we're going to find a common denominator. When you're adding and subtracting, it's only the numerators that you are adding and subtracting. You either add or you subtract. The denominator staying the same. With subtraction, kind of like with division, we're going to do the same thing. We're going to do the keep, change, flip, and change it to an addition problem. So very similar to division, we're going to do the keep, change, flip so that we can just change it to an addition problem. Okay, so we're going to go through a couple examples of this. First one, pretty simple. We are going to go ahead and do the keep, change, flip though. So the denominator I don't have to worry about. They all have the same denominator. So they both have an a plus 6. So we're good there. So the only thing that we have to do, I'm going to change. So this is going to stay the same. The subtraction is going to change to addition. And then I'm going to flip everything in my numerator. So that becomes a -5. So realize when I do the flip is only to the numerator. It's not changing the denominator at all. So I'm going to go ahead and add 2 plus -5 gives me a -3. The a plus 6 stays an a plus 6, and I'm done. Okay, so again, common denominator, they already had one. And then here, you just had to do the keep, change, flip. Okay, so on the next one, they do not have a common denominator. So I need to make them the same. So right here, when I'm making these the same, I have to figure out what do 4 and 7 have in common. If you ever get stuck, realize you can just multiply them together. So 4 and 7 are both going to have 28 in common. So looking at that, I could multiply this by 4z and this one by 7. And that's going to make them the same thing. So whenever I multiply them times each other, it makes them the same denominator. Remember, if I multiply the denominator, I also have to multiply the numerator. So both the numerator and the denominator are getting multiplied to make that common denominator. So right here, 7 times 3 is 21. On the bottom, 7 times 4z is going to give me 28z. Remember, I am going to change subtraction to an addition, and this becomes the opposite. So that's really a -1 times 4z is a -4z. On the bottom, 7 times 4z is the 28z. So now I have a common denominator. I can go ahead and add the two top parts of the numerator, but looking at this, these aren't like terms. I can't add them. So I'm just going to rewrite it. And I do want my variable in the front, so this is kind of like standard form. I'm going to put that -4z in the front plus 21 over 28z. Because I can't actually add these two again. This has a variable, this doesn't. So I'm just going to write that expression, and that denominator stayed 28z. All right, so looking at the next one, figuring out what they have in common. So 3 and 2, I can make both of those a 6. So if I multiply each one of them by each other, that makes it a 6. Now realize for your variable, this is an h squared, and I already have an h here. So I don't want to mess with the h squared. So on this side, I am just going to multiply this by 3. On this side, I do want to multiply it by 2, and I'm going to multiply it by another h as well. So realize when you're finding a common denominator, you're going to keep the highest variable. So if that h squared is my highest variable, this one stays the same. I'm going to have to multiply this by another h to make it an h squared. Okay, so now I'm going to multiply. So 2h times 2 on the top is 4h. 2h times 3h gives me that 6h squared. I'm adding, so I don't have to worry about keep, change, flip. Here, 3 times 3 is 9. 3 times 2h squared gives me that 6h squared again on the bottom. So that has common denominators now. So now I'm just going to add across the top. So again, these are not like terms. So when I write my answer, I'm just going to have the 4h plus 9, and then that 6h squared stays the same on the bottom. Okay, so these three, looking at these three, these are kind of like your basic ones just to make sure you kind of understand how to find that common denominator. Now we're going to do a couple where we might have to factor them out first. Okay, so it is a possibility that you have to factor them out first to find that common denominator. All right, so let's look at this one. So nothing to factor on this one, so I'm just going to bring this one down. It's staying the same. I'm adding. So on this one, realize this is a difference of squares. I can factor this out. So this is a b plus 2 and a b minus 2. So that's the denominator on this side. So now looking at what I need as a greatest common, or sorry, least common denominator. So figuring out what they have in common, realize they already both have a b plus 2. This one has a b minus 2 and this one doesn't. So that means I need to multiply this one by the b minus 2 to make them the same. Remember what you do to do the bottom, you have to do the top. So that means this one's not changing. I'm not multiplying this side by anything, so this one is staying the same. So over here, I'm going to multiply the 2b times the b minus 2. So realize it's like you're just distributing. So b times 2b is 2b squared. Negative 2 times 2b is negative 4b. And then on the bottom, again, we just leave it. We're not multiplying the denominator out. So now they both have the same denominator. They both have a b plus 2 and a b minus 2. So now I can go ahead and add across the top. So now looking across the top, I have 2b squared minus 4b plus 7. On the bottom, remember, we're just going to leave it like this. Okay, so now looking at this, you would want to double check to see if you can factor this top one out. So if I'm looking at this, remember I would slide the 2 over, so two things that multiply to give me 14 and add to give me negative 4, there's nothing that works. Okay, so two things that multiply to give me 14 would be 7 and 2, but there's no way to get a 4 from that, so that doesn't work. And then there's nothing else other than 14 and 1. So that doesn't factor, so that means I'm done. I just leave my answer like that. There's nothing to cancel out, there's nothing more to do. All right, so let's look at the next one. Again, we want to factor anything that we can. This one, there's nothing to factor. So this is just going to drop down. Here I can factor out that denominator, so they have a 3n in common, and that leaves me with an n plus 1. Okay, so looking at this, I need to figure out what is the greatest common or least common denominator. So I need to look at what do they have in common, what can I multiply by to make them the same. So obviously I have to multiply by an n plus 1 because this has an n plus 1. Okay, so I have to multiply this side by an n plus 1 because I need to get those the same. Now on this side, it already has an n plus 1. Now realizing here, this is a 9n squared. So I need to make this a 9n squared. That means I have to multiply it by 3n. Because if I multiply 3 times 3, that gives me 9. N times n is n squared. So that's going to give me that common denominator. So across the top here, I'm going to have 7n plus 7, because remember, I'm multiplying it to both of those. Here, we're not multiplying that out. We're going to make it easy on ourselves, and we're just going to write it 9n squared, and in parentheses, n plus 1. Over here, when I multiply this, n times 3n is 3n squared. And then here we just talked about 3n times 3n is that 9n squared, and you still have n plus 1 in parentheses. Okay, so now I've got common denominators, so now I can add those numerators, add straight across. So realize that's an n squared plus 7n plus 7. And then that denominator is staying the same. Okay, again, I would want to look at this and say, okay, can I factor this top part out more? So if I do 3 times 7, that's 21. Is there anything that multiplies to give me 21 and also adds to give me 7? No. So that means this can't be factored, so this is as simplified as I can get for that one. Okay, so maybe about 1 or 2 more of these. So these, again, are kind of all the same. So let's go ahead and factor this out. So that's staying g plus 2. I can factor out a greatest common factor of a 2 for this denominator. Now remember, I'm going to change this. So the whole keep, change, flip, I'm changing my subtraction to addition. And then remember, I'm flipping those signs. So that turns to a positive 2g, that turns to a positive 1. Okay, so I have 2g plus 1. And then I'm going to factor out this across the bottom. So it's a trinomial. So two things that multiply to give me 3 and add to give me a negative 4. So that's going to be a g minus 3 and a g minus 1. So first step, I did the keep change flip and I factored everything out. So now I'm looking at it, figuring out what do they have in common, what do I need to make, or what do I need to multiply. So realize they both have a g minus 1, so I'm good there. This one has a 2, this one doesn't. So I'm going to have to multiply this by 2. And then realize this one is missing that g minus 3. So this side gets multiplied by g minus 3. Okay? If you need to right here, this is where you can do the box method or you can do the FOIL method, but I am multiplying g minus 3 times g plus 2. So this is going to give me the g squared minus 3g plus 2g minus 6. Remember, those like terms are always in that middle. So if you do that FOIL method, remember that's what you're doing right here, the FOIL method, or you can do the box method. But when I multiply those together, you're going to get the g squared minus g minus 6. And then on the bottom, I have a 2, I have a g minus 3, and a g minus 1. That's my common denominator. Okay, on this one, all I have to do is multiply and distribute that 2. So that gives me 4g plus 2. Here, again, that common denominator is the same. So now they have a common denominator. Now I can add across the top. So now I'm going to add across here. I don't have anything else for the g squared. Okay, and then here I have a negative 1g plus 4g. So that's going to give me a positive 3g. And then negative 6 plus 2 is negative 4. Okay, so that's what it's simplified to. Now we always want to double check. Can I factor this one out again? And this one you can. So two things that multiply to give me a negative 4, but add to give me a positive 3. So that's going to be a positive 4 and a negative 1. So that one I can actually factor out again at the very end. Because we want to do that because now we can simplify and cancel some out. So they both had that factor of g minus 1. So that means, and I'm going to write it over here, my answer across the top is just the g plus 4. And across the bottom, I have that 2 and then the g minus 3. So again, at the very end, if you're left with a trinomial, see if you can factor that out again. These two, I could not. Those weren't factorable, so I was good. But this one, I can factor this out again, and those factors will cancel out right there. Okay? So looking at that again, these are all the same, so these are some extras if you guys want to practice this, but again, it's all the same concept. Make sure you can get that greatest common factor. Okay, now looking at the last little bit of this, we're going to look at some complex fractions. So really, when you have a complex fraction, all that is a fraction within a fraction. So it looks complex because I have a fraction being divided by another fraction. So that's kind of like a lot. So when you're looking at this, again, you have to find those common denominators. You're going to simplify what you can. So if you can add or subtract, once you find those common denominators, you will. And then remember, because it's division, we're going to do the keep, change, flip. So we're kind of putting together everything that we've done in the previous lesson and this lesson. Okay, so looking at this first one, nothing to do on the top. We're good there. So I'm going to rewrite this. That top part is staying the same. Okay, on the bottom, if I want to add these two, I need to get a common denominator. So that means here on this side, I'm going to be multiplying by y plus 4. On this side, I'm just multiplying by y. So I'm multiplying them times each other to get that common denominator. So this turns into the 1y over y times y plus 4. And then plus, when I multiply this out, that's going to give me the 2y plus 8 over y and y plus 4. All right, so first step, got a common denominator so I can add these two on the bottom. So now I am going to rewrite this. Still haven't touched that numerator yet. Now I'm going to go ahead and write it like this because now this is being divided by, and I'm going to go ahead and simplify this. So y plus 2y gives me the 3y plus 8. And then on the bottom, that's what I have. Okay, so now finishing this out, this is now a division. So remember, for division, we do the keep, change, flip. So looking at this one, I'm going to keep this one the same. I'm changing division to multiplication, and then I'm going to flip the second one. So I did keep, change, flip. So after I simplified the bottom part by that addition, this was my division problem, so I did the keep, change, flip. So now looking at this, I know I can cancel those out. Okay, so looking at multiplying across the top, I'm going to have 5y, and then across that bottom, I'm just going to have the 3y plus 8. And that's it. That's my answer. Okay, so again, it looks like a lot, but you're just going to simplify what you can. So if you have an addition or subtraction problem, you're going to simplify that first, and then it just becomes a division problem, which you do the keep, change, flip, and you multiply and cancel out what you can. Okay, so let's do one more. So looking at this one, I do have fractions that I'm subtracting on the top and the bottom. So we have to get both of them to be a common denominator. So remember, for this first one, I'm going to change that. So keep, change, flip again. So if I look at the first one, this is a 6, this is a 3. I know I can make this a 6 if I multiply that by 2. So I'm going to rewrite that. So this one is staying the same. Plus, so 2 times negative f is negative 2f over 6. So that's the top part. On the bottom, I have a 5 and a 10, so that means I could multiply this side by 2. So that becomes 2f over 10 plus negative 7 over 10. Okay, so now I'm going to go ahead and rewrite that. So I'm going to go ahead and f plus negative 2f. That's going to give me a negative f over 6 divided by this bottom part. So remember, I can't actually subtract those, so that's just going to be 2f minus 7 over 10. So that's my division problem. So now I'm doing the keep, change, flip. So keep this the same, change division to multiplication, and then I am flipping this one. So now looking at this, what can we simplify? So there's nothing I can cancel this way, but if you realize 6 and 10 are both divisible by 2, so that becomes a 5, that becomes a 3. So always reduce where you can. So across the top, I'm going to have a negative 5f. Across the bottom, I just have 3 times the 2f minus 7, and I'm just going to leave it like that. Okay, so again, with these complex fractions, all you're doing is simplifying, adding or subtracting what you can on the numerator and the denominator. Okay, and then it becomes a division problem, which you do the keep, change, flip.